This video is going to be about particle simulations. And I'm just going to run this particle simulation as a method of generating geometry. There are other reasons you might run a particle simulation for some kind of visual effect, some kind of particle effect from like a weapon or a sci-fi event, but this one's going to be specifically focused on using the particles to generate geometry, which is a bit different. And that's mostly in like how they're rendered and the kind of processes they'll use. If you want to do them for visual effects, it's quite easy, and I recommend you just looking on to YouTube, and there'll be tons of videos available for how to do that. To begin, let's just see how to add a particle system. I'm just in the default layout, and this is actually very handy for particles because really we're going to make use of this timeline a lot, and just having it down here at the bottom anchored is very, very handy. So to do a particle system though, you just select an initial object. I'm just going to run them off of this initial cube, the default cube that's in the scene, but it could be anything. And you just go into the particle properties tab, which is totally empty. It's a little intimidating, right? But all you got to do is click the plus button, and this will add a particle emitter. I have a separate video on the hair system, so we're not going to talk about that. In this, we're just going to focus on the emitter. And you'll see this dot that has appeared, and this is a particle. Now, even just with the default settings, if I hit play, you'll see the particles being emitted from the cube. And by default, there is gravity in every scene, and so they're all being affected by gravity and falling straight downwards. Or they also have a bit of an initial velocity off of the cube, so you can see them kind of arcing down like you might see in a physics textbook problem. Well, to really make sense of all of this, let's just kind of go through some of the different settings. So the number, of course, is the number of particles in the particle simulation. So if I really crank this up, it can get quite demanding on your machine. The default number is okay, and I'll actually probably lower it from this for what we're doing. I might even stick down to something like 200 or even lower, down to even like 50 particles. It really depends on what you're using it for, but I'll just start with 200 and we'll go from there. Seed is essentially the starting random location for the particles. So if you want to perfectly replicate a simulation, you want to use the same seed because it will interpolate all the data from that base point, but the seed allows you to randomize the base point. So if you want unique simulations, you can play with the seed. I'll just leave it at 0, so it's not a big deal. The frame start and frame end is the length of frames, the number of frames where these particles are being emitted. So it goes from 1 to 200, and there are 200 particles, so that means that every one frame a particle is being emitted. So if your frame rate is a normal video of like 24 frames per second, there are going to be 24 particles per second. The lifetime is how long each one of those particles lives. So if you'll notice, they kind of disappear after a time. And so the first particle actually dies or vanishes at frame 50, and a particle that comes out at frame 10 will vanish at frame 60. So if I change this to being 200, now all of the particles will live for the entire duration of the simulation and continue falling all the way to frame 200 when they start disappearing. Now, what this also means is that the last particle, which is emitted at frame 200, will still have a lifetime of 200. So really, it would go all the way out to 400. And I can just extend the timeline by typing in to the end frame on the timeline. So really, this simulation with these current settings, particles will continue to be in the scene until frame 400. You'll see though, they start to vanish around here, and there the final ones are going, and boom, they end at frame 400. So we will be making use of some of these settings later on. But of course you can also have this lifetime randomness in here. The next thing I'm going to do is this little nested menu, the source. And I think this one is quite handy. So it tells you how these particles are being emitted from the object. So by default they're coming from the faces. So with something like a cube, you'll see it gives them almost like there's planes, right? So they have kind of this constriction on how they are ejecting. And one way we can mess with that a bit is you can change it to volume. And now the particles will emit from different locations within the box as opposed to only emitting from the faces. So I'll actually leave this as volume for most of what I'm doing. Here you can adjust some additional particles per face, or the amount of jittering, which is the kind of randomness in their distribution. But I think really the most useful one is the volume setting there. A cache is essentially saving a simulation. So if I want to save the simulation and move on to a different simulation or set something else up, you want to bake the simulation. And this is going to store that simulation data on your computer. Then what you could even do is import that simulation into another file, for example. This becomes really handy once we get into more so with the liquid simulations, but it's quite useful for the particle simulations as well. And I'll be baking a bit as well in here probably. Now, the velocity, of course, is exactly what it says. It is the initial velocity of these particles. And one of the ones that the only thing I really end up changing for most of my uses on this is right here. It starts with a default of 1 meter per second normal to its ejection plane. So for example, in the default case where I was ejecting from faces, it had an initial velocity of 1 meter per second. If I turn that off, you'll see now there's no more initial velocity in a direction, so everything just falls straight downward. Or if I really crank that and hit play, you'll see that they shoot out from the sides. But I'm going to leave that at 0. Rotation, we'll get into that more after a bit. And the last and most useful part I find are the field weights. We're going to get into some of these other pieces as we do specific things, but the field weights is where you can scene-wide adjust the impact of a particular kind of force. For example, gravity is in by default, but if I turn gravity off and hit play, now, because there is no initial velocity and there's no force, the particles just sit still. They just pop into existence. And this is a great segue into now adding custom forces into the scene. So I have turned gravity off, but let's say we still want some kind of movement. Well, if we go to add, you'll see here there is a force field section, and there are many types of forces that you can add to a scene. I encourage you to play around with them. There's a lot of amazing ones. The two that I'm really going to focus on today are the turbulence and the generic force. Of course, a vortex is pretty cool. Wind is pretty cool. But turbulence is probably the most interesting one, in my opinion. So we've added a turbulence to the scene, and to adjust its properties, you want to select it and go to the Physics Properties tab. This will let you adjust things like the strength, the size of the field, and the flow. And these are the three main settings that we'll be adjusting. The flow is essentially the friction or the drag, and I find that I quite like the flow. It has a really interesting form innately to it, and the size will be the scale or the distribution from this point. So I'm just gonna, I'll make it a kind of small size, and I'll increase the strength just a little bit. Let's hit play, and you'll see immediately what that's doing is it's starting to twist and manipulate these particles through the turbulence. And I'm going to decrease the flow a little bit so they'll move a bit faster, and I'm going to increase the size just a hair. And let's see about it now. There we can start to see it's a bit more dramatic, and I'll just keep messing around with these a bit until they seem interesting. That looks pretty cool. So we'll run with this for now, but you can just play around with these settings and adjust it to your heart's content. Where this starts to get really spicy is when you add in multiple forces, because forces will interact and create a field around, so the particles will respond to the field of the forces. A force field is essentially like a gravity field, but the important thing to know is that when it is set up with a positive value, it is repulsive, but if you make it negative, it is attractive. So if I just give it a negative value of 2, when I hit play, you'll see that these particles that start here are still affected by the turbulence, but they are being pulled towards this attractive force field. And you could really kind of go crazy with this if you just press Shift D to make a copy, for example. You can now have 2 force fields, and so the particles will respond to both of them. Now if I pull this one farther away, I might be able to pull the particles apart, because there should be pulls in both directions, and I can impact this by making them both a bit stronger. You can see if I make one too strong though, they're just pulled into that one. I can add additional forces into the scene as well. For example, I could add in a vortex, which will give it a spiraling action in the direction of this spiral, and I will turn it maybe at an angle, and we'll hit play here. I'm actually going to reduce the turbulence force, this flow here, so that particles can respond more freely to the other forces. You'll see they're kind of spiraling into a ball here. Now you can get really crazy with this by actually animating the forces as well. And you would do that by keyframing the location of the forces. So for example, the location for this force at frame 1 is here, and I could just click these dots, and then I could come up here to frame 250 and move the force and keyframe its new location. So now over that time this force will be moving, and you'll see as it does that, it starts to pull the particles to it. Now you can adjust these forces ad nauseum. You can have all sorts of fun with it. You can make a huge variety of different incarnations of this. But what we're going to do before we get too much farther is I'm actually going to turn these particles into something else other than these kind of spherical sprites. So I'm going to add in another cube to the scene, and I'm just going to slide it over here to the side. What I'm going to use this cube for is in the particles render tab, it's currently rendered as a halo, but if I pick object, it now allows me to pick an instance object for it to represent the particles as. Now if I hit play, you'll see that now the particles are actually cubes. And that looks pretty interesting. One thing I don't really like is that these particles are dying still, and they're dying, and also they're taking a long time to emit. So what I can do is I'm going to make it only go to frame 30 when they're emitted, but I'm going to increase the lifetime to 300. And now more particles will be in the scene because they are more being emitted all at once. Which, what I'm noticing is that this force being attractive is maybe a bit too strong. So I think as it goes, we're actually going to make it repulsive. And I just did that by keyframing the value of the strength at the two different keyframes. So now when the force starts to go through, they'll ball up, but then it's going to start pushing them away. I'm going to spend a second to adjust this. I'm not quite happy with it yet, but I'm just going to speed this part up. Okay, so I made some adjustments to the settings on this system. I just increased the number of the particles slightly, increased their lifetime, and made it so that they all emit immediately. So all of the particles are always present. And what I'm going to do is I'm going to adjust the scale of these cubes. So by default here, they're all set to be the same size, and it's 0.05 the scale of the original object. But what I'm going to do is I'm going to randomize that and then increase their scale to say 0.2. I'm also going to use two settings to hide this main cube. So I'm going to, in the render, uncheck show emitter, and also in the viewport display, I'm going to uncheck show emitter. So now I only see the cubes that are in the simulation. And as I'm watching it, I'm just going to be keeping my eyes open for some kind of interesting configurations. I think, of course, once it starts to blob together again, that's quite nice. And similarly, towards the beginning, there are some nice moments as well. But what I'm going to do is I'm going to increase the scale a bit more so that they're more together. Because what I'm looking to do here is create a singular kind of cohesive object out of this. Might actually back it up, decrease the randomness a little bit, and increase the scale a bit more. Now, a number of these are really cool, but I'm not as much of a fan of this scale when they kind of ball up. So I'm just going to kind of browse through the frames, and I quite like this moment right here. So let's say we're happy with this exact configuration. What I'm going to do is make a new collection, because to turn these into an object or a mesh, what I have to do is I have to convert all of these particles into meshes. And so when I do that, it's going to create, because I have 250 of them, it's going to create 250 distinct objects. And to do that, what I need to do is I click on the modifier properties, and you'll see here I have an option to make the instances real. And if I do that, they have all populated into my outliner browser. Now, I made this new collection, and I'm actually just going to drag all of those into this new collection. And while I have them selected, if I don't unselect them, I can just shift click one of these and press Control J, and now I have merged them together. But what you're seeing outside of this now is actually the same particle simulation running now on that object of merged pieces. And of course that is, it is pretty interesting. It's got a very high level of complexity and detail, but perhaps that's too much detail for what we're doing. And so if you want to not have that, you can subtract the particle system away. And now you'll see that you have this collective object. You also see something kind of curious has happened to the original cube in that it also received that joining and collapsing. But now that we have this object generated from the particles, we can do our normal different operations to it. And I think that's a pretty nice area for potential, right? Because I've already generated some quite complex formwork from these alone.